All right, in this part two section, we're going to just review special right triangles. You've seen these before in geometry, so nothing too new here. You get your 45, 45, 90 triangle. The relationship is set up like this. The two shorter sides here, the legs, would be the same value, and the hypotenuse would be whatever that value is, let's say x times root 2. Okay. On a 30, 60, 90 triangle, most things are actually based off of the 30-degree angle, so what's across from that. So across from 30 degrees is the x. If you double that, you get the hypotenuse. If you take that value, that x, and times it by root 3, you get the longer leg that's across from 60. So that's the relationship here. We're definitely going to explore some trig values for special angles, 30, 45, and 60, sine, cosine, tangent, all that good stuff. You see some numbers here. We'll get more into that as we progress through, especially when we get into like what we call the unit circle. But for now, I just kind of want to show you that there are some values here. You might even see that certain values, like sine of 30, for example, is the same as the cosine of 60. So there's some relationships that go on there. So we'll get into that down the road. Let's just kind of review with an example. So we want to find the value of x in this situation. We could use SOHCAHTOA, but in many cases it could just be faster or easier. You don't even need a calculator if you know the special relationship. So let's see. All right, here's 30 degree. I'm trying to find this side. There's no direct relationship between the hypotenuse and this one. If you go back to our relationship here, you can't go easily from here to here. You need to know the side across from 30. So if we look at this, like, okay, this is the hypotenuse. Well, let's see, that's twice as big as this side. So actually what I could do is just cut this in half. So this side has to be 4. And now that I have this side, I can easily get this side. It would have to be 4 times the root 3. I'm just using relationships there. Sometimes you can easily go from one to another, and sometimes you got to kind of work around it. Something like this too. Once again, we have the hypotenuse. We're trying to look for this leg on the 45, 45, 90 triangle. Well, usually there's a root 2 involved here. I don't see a root 2. If this was 6 root 2, this would be super easy. In this case, though, I'm essentially dividing by root 2 to get the x value. So that's what I need to do here. I need to take this 6 and divide by root 2. Now that's an okay answer, but let's try to clean it up. We don't want any square roots on the bottom, so we can multiply top and bottom by root 2. So how about 6 root 2 over 2, which then goes one step further. 6 divided by 2 gives you 3. So 3 root 2 would be this side, and it's actually also the length of this side as well, since they're the same. On the next page, you get some practice here, so try these out. You might also notice on the page after that, there are some problems that require you to kind of two triangles combined. Like maybe you need to find, in order to find x, you got to find some stuff on this triangle, then to help you with this triangle. So try those out and bring questions to class.